Welcome to the Women in STEM podcast. Today, we're thrilled to have two incredible women from Engineering Tomorrow, a non-profit organization dedicated to broadening access to engineering. Please welcome Joanna and Betsy, both staff engineers. Thank you for joining us. Would you like to introduce yourself, please?
Yes, thank you so much for having us, Kelly. It's great to be here today. My name's Joanna Caudle, and I have an educational background in physics and mechanical engineering. And I spent the first half of my career as a mechanical engineer working in the power generation sector for a big global construction company. I worked on nuclear plants, fossil fuel combined cycle plants, and some related systems work associated with the power generation business. And then I spent the second half of my career working as an educator in an all-girls private high school in the Washington, D.C. area. And there I taught physics. I started an engineering elective, and I also helped coordinate the STEM program and lead the science department at that school.
Yes, and thanks again, Kelly, for having us here. So I'm Betsy Fortman, and I have been working in the space industry. Gosh, I started back in 1995 as a co-op working with NASA. And over the years, I worked with different contractors as well as the government in NASA, and also consulting firm with Sophic Synergistics. And I'm so passionate about bringing STEM to students. And I love the fact that Engineering Tomorrow provides us that opportunity. And so that's kind of why I'm here. And I love the journey.
Joanna, as someone who's transitioned from industry to education, can you tell us a bit about Engineering Tomorrow's mission and how it seeks to address the challenges you've observed in both sectors?
Yes, I'd be happy to. So I think at its core, Engineering Tomorrow is working to expose a diverse array of students to the world of engineering. We provide kits of materials at no cost to teachers, as long as a really rich group of curriculum resources so that they can easily integrate engineering challenges into their classroom, authentic engineering challenges into the classroom. And I think why this resonates so much with me is, as Betsy said, we want to make the exposure to engineering much more every day in our high school classrooms in the United States. I don't think it's any secret that the United States, while having very high quality engineering programs, we do not graduate as many engineers as some other major economic countries. And we need to do more. And I think that was a real driving force behind our founder, Bill Woodburn's desire to get more students interested in engineering. When I started teaching in high school, and this was in 2002, many of my students didn't really know much about what engineers did. And I really, at that time, felt driven to try to expose them to show them how engineers work on some of the most complex problems that humanity has to solve. My school had a very strong social justice component, and I felt like that was the pathway to interest particularly women in STEM careers, to show them that they were really helping the world by doing the work that engineers do. And I think that's something also that Engineering Tomorrow has done such a nice job of.
Betsy, with your background in aerospace engineering, how does Engineering Tomorrow inspire students to consider fields that they might not have been exposed to otherwise?
I love that question, Kelly. With Engineering Tomorrow, there are just so many labs that we have. I feel like there's something just for everyone, whether it's building a spacecraft or actually creating a 3D printed prosthetic. And TT has over 20 labs. Some of the things that we can concentrate on are like clean water. How do we filter water systems? Embedded circuits, structural engineering by building bridges, electric vehicles, and even genetics and biomedical engineering. What I love though is that it's at no cost to the teachers and students. And all the labs are designed and delivered by engineers. And so, if a teacher is trying to bring STEM to their students, they don't have to have all the answers. We will provide engineers that will help and support them along the way. And so I really love that it gives both the students and the teachers connections to current professionals in the field, but also we're connecting college mentors and students that were recently in their shoes, where they get to ask questions, and find out what it's like to go to college, what's hard about it, what different courses should they be taking to start thinking ahead, for their path and their careers. And so I love that. It's so rewarding to me and inspiring as we see the students when they're working on some of these designs light up with their excitement when their design all of a sudden works and their electric vehicle shoots off and takes down the road. So to me, it's about serving those like underserved communities and giving them the opportunity and the resources to invent and design. And I feel like if we can do that, all of the inequalities begin to melt away and they can see themselves in this bright new way and realize they can be or do anything if they put their mind to it.
Speaking of inequalities, let's talk about breaking barriers. Joanna, as an educator, how have you seen Engineering Tomorrow's programs impact students, especially those from underrepresented groups?
Well, I think teachers are very busy people, professionals. And one thing that I think has been a game changer for the program is that Engineering Tomorrow has had a professional engineer record an introduction to our challenges. And then we, together with our college interns, have developed some really great resources. And so what we really are trying to do, what's front of mind for us all the time, is how can we make teachers' lives easier so they can easily incorporate these programs, these challenges into their classroom. And the feedback that we're getting is that we're doing just that. I was at a teacher professional development class, teaching a little bit about Engineering Tomorrow. And one teacher that I was working with, who's an environmental science teacher, told the group of students, the other educators in the room, I have not put together an electric circuit since I was, a high school student myself. I don't really remember how to do those things, but I feel confident to offer an electric vehicle challenge in my environmental science class because I know I've got some college mentors and Engineering Tomorrow engineers there to support me. And I know that my students are actually going to be able to problem solve themselves and figure out how to make things work. And that is really authentic learning, and some of the best ways that students can learn and retain new information. So for me, the way the barriers have broken down in our program and allowed the reach to just grow exponentially in high schools across the country is that we're giving the teachers that little extra confidence that they can do this, even if they don't feel like experts in a particular area. And I just wanted to quickly read some feedback we got from a teacher after one of our lab days recently. It said, we all love and appreciate the resources from Engineering Tomorrow that have helped my 100% English language learners students this year. Lots of students want to join the class because it is a project-based learning class, but with limited space. I now have 2 classes with 55 students all together. The intro video, teacher's guide, and student workbook really help to deliver the content. And I guess she said her wish was, could we start translating our content into Spanish so that we could even further help students and reach wider groups of students. So to me, making it easy on teachers is one of our most important goals.
Yes, I think that is something that is pretty much echoed around the world, making it more easier for teacher. And I love that you included that feedback from the teacher. I think that really shines a light. Betsy, considering your experience with NASA and international collaborations, how do you think diversity in engineering contributes to solving global challenges?
Oh, wow. What a wonderful question. So in my time, I had worked in the International Space Station. In that project, we have partners all over the globe. We have, JAXA working in Japan on certain items. We have Europe working on certain items, the United States and Russia. And I was blessed to have worked with some of the most amazing and innovative engineers on the planet. It's so impressive to me to see us all speaking in different languages and but having one common goal and one mission that unites us and inspires. So for us, of course, that was to fly humans safely to and from orbit. But in my time working overseas, what is so cool is that the instructors and the astronauts and the cosmonauts, I was always amazed by their diversity of thought as to how they're approaching a given problem. But it really just boils down to the mathematics and the physics and being able to take a step back and look at how someone else is looking at that problem and seeing that common ground. So I've really enjoyed working with our international partners. And I think they strengthen us and help us to get that diversity in both our thoughts and opinions and coming together to find the best design. I have to say that every astronaut I've ever talked to post-flight has commented when they look back at Earth, they don't see all these lines drawn all across the world separating our countries. What they see is one united planet and how fragile and how awe-inspiring it is. And really, when we all work together, whether that's here on the planet or in space, we really can do amazing things together.
That was a great response, and I like how you connected everything together. Now, I'm sure that some of the listeners are still quite curious around engineering's program and wanting to get a bit more details. Joanna, as someone who develops these programs, how do you ensure that they're engaging and relevant to students? I know that the world is changing, technology is changing, so how do you make sure to keep it up to date?
Great question. We at Engineering Tomorrow generally do our lab development over the summer, and we engage the help of current engineering college students. And we rely on them heavily to make sure that the content that we're putting together resonates with them. They're a lot closer to high school than the staff engineers are. And so we really want to have them offer educational experiences that will resonate with them, things they found really exciting in their classes. In addition, we are trying to always offer kind of the latest type of challenges that we think students are hearing about in their in the news, in social media, etc. So electric vehicles is one of our most popular challenges. Renewable energy is another one, but we're also offering things. A new one we're offering this year is semiconductors, so that students gain an understanding of how computers can become ever faster. We're also offering one in machine learning and artificial intelligence because that's so much a part of the technology today. So we're constantly striving to add more new content that also aligns well with high school science class curriculums as well. To that point, we just added a new class this year, a new challenge called site remediation, which is very much a part of the environmental science curriculum. So we still could do more. We have teachers asking us if we could do something with more direct chemistry applications. And we take that feedback very seriously and try to keep building the program.
Betsy, how do you incorporate your real-world engineering experience into these labs to give students a taste of what engineering is really like? I'm sure that's something that really excites them.
Oh, thank you, Kelly. Yes, in all of our Engineering Tomorrow labs, we have so many topics that deal with these real world problems. And of course, whichever engineer you have assigned to your session, they're going to have a different background. There may be some that are in construction management and can talk about the structural and aesthetic designs. For me, that's obviously space. And with space exploration, I find that it's so cross-cutting so that it really fits into almost any one of our labs here. For example, when we talk about water filtration, I show pictures of what our water filtration on orbit looks like. I show how we store the water and how we have to keep it clean and how we filter out all the contaminants and make sure that it's safe enough to drink. For 3D printing, I love this lab because I get to showcase Butch Wilmore, which is one of the astronauts who had used one of their first 3D printed wrenches in space. And it's incredible the amount of savings, both mass and space itself, and the money required to ship something to space. And so if you're sending up thousands and thousands of tools and you don't know if you're even going to need it, if something's going to break, but now we have the ability to print those wrenches and other tools on demand in space. So I love showcasing that particular item in the 3D printing labs. For green hydrogen, it's talking all about electrolysis and how we can take water and split apart the H2O into hydrogen and oxygen. And so I show the system on the space station that does this exact chemical reaction, and that how we want to save that oxygen so we continue having oxygen for our astronauts on board, and things like that. Obviously, our astrodynamics and aerodynamics probably speak for themselves as we're building the vehicles. We talk about how we balance all these forces and how all our vehicles have to be very symmetric in that it can distribute forces, but also balance them to optimize flight. The same is true with electric vehicles as well. And then if you think about the other side, like some of the biomedical and genetics engineering that we have, I love to showcase the twins in the study of the long duration on the one twin versus the short duration, and to see those effects as well. And so there's just so many applications. I find space and exploration is so cross-cutting across all the disciplines.
Now let's delve into a bit more around your personal journeys and some advice that you might have. Joanne, what inspired you to make your transition from industry to teaching, and how has that influenced your work with Engineering Tomorrow? Quick break before we get back to our conversation. I want to remind you to follow, rate, and review the Women in STEM podcast on whatever streaming platform. Your support really helps us to reach more listeners and continue to bring inspiring stories and valuable insight. Don't forget to share this episode with your friends and colleagues who might be interested in learning a bit more about women in STEM. Also, make sure to check out our new LinkedIn page, the Women in STEM podcast, where you get to see some of the latest advancements in technology and learn more about women in STEM. And please make sure to check the bio to see where you can vote for the Women in STEM podcast.
Great question again. So as a mechanical engineer working for a big construction company, you often are going to a job site and working on the startup and operation of whatever it is that you're building. So while I love to travel, I was traveling an awful lot for my job. And I'm married, I have 2 children. And when my children were young, I was finding it quite difficult to be away from them for so long. And at that time, so this was the late 90s and early 2000s, it was hard as a woman engineer, I felt, to say, I want to stay grounded here, to help my children with schoolwork and things like that. I felt like whereas some of the men that I worked with could say, "Oh, I'm leaving early to go to a softball game for my daughter," it was I, as a woman in this uh, majority male office that I worked in, didn't want to really be saying anything that was going to um, make me stand out as the woman engineer on the team. And so after a lot of soul searching, I thought, well, I think I would like to take some time off um, away from this job so that I can focus on my young children. And I was fortunate to be able to find a job in teaching. It was something that I always thought I would love doing. I have family members who are teachers, so I know what a rewarding career it can be. And I thought maybe I could do this for a short period of time, and then lean back into my previous job. And what I found was I really loved teaching, particularly teaching young women um, how exciting a STEM career can be, and helping the science department at my school grow and grow, and also show them how exciting engineering can be. As I mentioned, the school had a very strong social justice component as part of its curriculum. And I feel like Engineering Tomorrow has that same focus, trying to show students what good engineers can do in the world. And so for me, it was a very easy transition. I began volunteering with Engineering Tomorrow while I was a teacher, and then joined them on their staff just this past year, actually, after doing about 4 years of volunteering with them. So I'm very passionate um, about the mission of the program, because I feel like it echoes what drove me to stay in education for 20 years and try to do that with students as well.
Thank you for your transparency and sharing some of the struggles and the reason why you've decided to make that transition. I think a lot of women listening can definitely relate to what you said. Betsy, with such an impressive career in aerospace, what motivated you to get involved with Engineering Tomorrow?
That's a wonderful question. So part of my career, I knew that I was very passionate about teaching and I was very passionate about space. And it's kind of funny how my career led me down the path where I was teaching astronauts. And so I got to go to Russia where I was, basically in classes with them and helping prepare them for their exams and make sure they were ready for the flight, working on simulations and all of that. And I found that I loved that, but I also felt like I had a bigger mission, and that it was to reach even more students, to help more students realize they could be them. And so I actually went and started teaching at a private school. I was teaching chemistry at a high school for a while I was still working at NASA, and I really enjoyed that. And I ended up opening my own tutoring LLC in order to tutor math and science. And as I was doing that, I was starting to make these kits and I wanted to form these labs. And I came across Engineering Tomorrow and I said, this is it. This is what I need. And so that's how I ended up connecting with Engineering Tomorrow. And it's been a wonderful journey ever since.
Thank you for sharing that. And I have a unusual question to ask you guys both, but I feel like you would be the perfect people to ask this question to, considering you've been working with Engineering Tomorrow, and I'm sure you've come across a lot of different career paths. I'm curious to know, are there any career paths that you've heard of that maybe not a lot of people might have heard of it before and might be considered a bit unusual?
Love that question. I think some of the careers that the future women in STEM will be having have not even been imagined yet. I think the kinds of um, rapid changes in technology that are happening are going to foster a whole new group of career paths. And I'd hope will be very interesting to women and will encourage more women to enter a STEM field. Some things that have come up lately, I was working on that. I mentioned I was working on that remediated sites challenge just recently, and I was working with an environmental engineer to develop that. And I learned that the EPA, the Environmental Protection Agency here in the US, and I'm sure there's a similar agency in the UK as well, the jobs that are available in that realm are really quite interesting, from somebody who's a scientist, but also can be part of rescue missions, somebody who might be a first responder in a remediated site situation. And so I was quite excited to think about how you could be studying a scientific area or a engineering area, but it would be taking you to places you never could have imagined and being on the ground trying to resolve a problem right away. So to me, that was kind of an exciting thing to think about. I know many of my students don't like to think about the typical cliche version of an engineer with glasses and a pocket protector. I think I want to show engineers as problem solvers out in the world, working on problems every day. So that was an unusual career path that I wasn't aware of before.
That's a great one. I was thinking about, we just had a special event day back on October 11th. And this young woman, Miral is her name, she had a very big passion for dancing, and a very big passion for electrical engineering. And she ended up putting these two together to make her career. And now she works with these artists and songwriters and people you probably know in the mainstream pop culture, where she uses her electrical designs to light up their outfits based on the timing of the music on the stage. It was so impressive and so cool. So if you ever have a chance to check that particular special event out, I would highly recommend it. And I think that really goes to show that whatever you are excited and passionate about, as a young student, you can probably find ways to incorporate whatever excites you. And if you're doing something you love, people are going to be naturally drawn to you, and you're going to enjoy what you're doing. It will never be like a job that's you have to like get up and go to work. You're going to bounce out of bed and want to be doing what you love. And so I just want students to know that, it isn't just one clear cut, I go to school, I do this and I do that. You find what you love. And as you start getting down your career paths and you try things out, you find what you like and you find the things you don't like. And that's okay too, because it helps kind of guide you along the process. Now, with that said, I don't want everyone to think, oh, this is going to be super easy. It's not easy, but I tell you, it is so worth it to be doing something you're excited about and to be solving real world problems. For us here in the US and probably for the UK, I'm guessing it's pretty easy to have clean water. There are so many people across the world that that's not a true reality. The same with bridges and being able to get to just medical care and school. I think it's something like 7 billion people don't have the ability to cross, streams just to get to school, and big rivers and ravines. And so I just want people across the globe to know they can do it if they put their mind to it and if they're willing to put in the work.
Wow, that's so inspiring. And yes, Joanne, you mentioned how there's so many jobs that haven't even been thought up yet, as well as Betsy, you mentioning the integration of things that you already love that you can integrate it into engineering. As we wrap up, I would love for you each to share one piece of advice for young women who are considering a career in engineering or the STEM field.
Thank you so much for this question. I think it was the favorite one that you provided. I'll start by saying that a quote that has really stayed with me throughout my life, and one that I share a lot with my former students, is by Louisa May Alcott. And she says, I am not afraid of the storm, for I'm learning how to sail my ship. I think sometimes young women don't consider a career in STEM or taking more challenging STEM classes in school because they have a fear that they might not do as well as they're used to doing in some of their other classes. But some advice I want to give you today is that if you can overcome that fear to put some energy into endeavors that are completely new to you, I promise you, you will learn so much about yourself. If you can push yourself to take risks, even when the outcome may be a total flop, it really can teach you something about yourself. And you're probably saying, I can't imagine ever wanting to do this. But I really hope you take a class one day where the end result has you kissing your report card because you earned a beautiful C minus. And I know that sounds counterproductive, but I'm sure that it is often in our struggles that we really learn what we're capable of. Engineers and scientists work on very complex problems that can only be solved by a diverse group of thinkers that bring a varied skill set and creativity to the problem. And we really need young people who are willing to try new things and share their ideas confidently with their team to find a solution. That takes practice and experience to build that confidence. So you've got to put yourself in the way of risk-taking in order to do that. One of my most vivid academic memories from college was my semester in microcomputer interfacing was the name of the course. An example of a little microprocessor computer interface would be maybe the heating thermostat in your home that you can program to adjust the temperature at various times of the day. And I know now we're much more familiar with these systems for all kinds of things, from turning on the lights when we get home or starting dinner. But back in the late 80s when I was in college, this class was very new. And the things that we were working with were just electronic breadboards and circuit components and primitive mini processing chips. And so we were putting together these simple circuits to control various devices like lights and to sense our surroundings. And maybe that doesn't sound too exciting, I know, but for someone like me who I really liked programming, I liked building things, the chance to work on some of these early computer processing circuits seemed like something I might really enjoy. And I stress the word might because it was definitely a new type of class for me. And it was in a completely different department than the physics department where I was taking a lot of my coursework. That first day, when I started the class, it felt like I walked into a new school. I was the only girl in the class, which wasn't always a surprise, but it was in a completely different part of the school, down in the basement of the science building. So that sort of felt like a dungeon. You know, needless to say, I was nervous. And the first few classes were rough. I didn't know anyone, and the technical jargon was spewing out like in the class discussion, like like this never-ending stream. And I'm sure you can imagine that I thought about dropping the course. Would you drop the course? Perhaps so. But just as I was starting to feel hopeless, I got a few helpful tips from my fellow new classmates. And my professor gave me some encouraging words and persuaded me to stick it out. And I can't say that the class got much easier. It was a long slog all the way through. However, I really learned so much about my perceived limits and about overcoming my fear of being the weak link in the class and learning how to ask for help. And finally, getting to know and learn from some fine fellows who were brilliant. Our small class and my professor became a very close-knit bunch, experimenting with this newfound technology, making mistakes often and helping each other to figure out what was going wrong. I wouldn't know it then, but the experience I gained became even more important to me when I transferred to engineering school, and I found myself in strange surroundings again as the lone girl in some of my upper level mechanical engineering courses. Learning how to navigate the new school and develop friendships and peer mentors would be so important to my success moving forward. Luckily today, STEM classrooms are quite different and more diverse, but the very important skill to seek out friendships and peer mentors at school and in your future career remains. And as a final tip, I would say, try not to expend too much energy worrying about having it all figured out right now. Believe me, none of your peers do. A typical career spans more than 40 years. No one decision is going to carry too much weight in the grand scheme of things. Keep taking risks. Keep trying new things. Try to learn as much as you can about yourself and what challenges and inspires you. We spend a lot of time at our jobs, so try to always keep learning and growing in every new position. It takes a lifetime to assess what your potential is and how to, quote, learn how to sail your ship. My wish for you is that you fully embrace the struggles of that really hard class or that difficult boss or that really challenging project and turn those struggles into solutions in the future or lessons you've learned as you progress through your career.
Yeah, that was great, Joanna. I'm definitely an example as well, as I didn't just stick with one career path and that was it. I found myself kind of, as I found I was good at something, then I ended up going to Russia to do that. And, you just end up going with the flow, finding what's working and what's right. And I think that's a wonderful suggestion. I also want to emphasize to the girls out there, like, to me, if you're doing a good job and you love what you're doing, it doesn't matter if you're a man or female, or a dog. Like, to me, the most important thing is that you're doing your job. And I feel like if you're doing good, people are going to see that, and they're not going to care what you are. They're going to care that you are involved and you're passionate about your work. And I find that is probably my biggest suggestion, is to just, dive into the work, be good at what you do, love what you do. And if you need to pivot, like Joanna is suggesting as well.
Those were both fantastic pieces of advice. How best can people connect with you?
Well, we would love to have you engage with some of our special lab days that are coming up. Of course, please feel free to reach out on my LinkedIn. I would love to answer follow-up questions or provide any additional advice to young women in engineering. That would be wonderful. I would be very happy to do that. Betsy and I did want to let you know about a couple of upcoming lab days. We are, this year in particular, trying to really showcase women in STEM as part of our special event days. So on December 4th, we have an astrodynamics event. Betsy is going to be the lead engineer on that, but we're going to have a keynote speaker, Camille Elizabeth Bergen, and she is known as the Galactic Gal. I think she's on social media, but she's really trying to broadcast the fun of STEM as part of the work she does.
Yeah, that was a good one. We also have clean water coming up, and to showcase that one of our engineers, Lauren Sawyer, is going to be our lead for that. And there's also a team of women in the industry from Engineers Without Borders who will be our keynote speaker that day. So that's one you don't want to miss as well.
And finally, right in January, at the end of January, we have our pharmaceuticals challenge coming up. And in that one, we are going to have a all-female panel, 3 engineers, brilliant women that are working in the industry now as part of our keynote speaker. So check our website, engineeringtomorrow.org. We would love to explore what we have on offer there. And please reach out if you have any questions. We'd love to follow up with you.
For sure. Kelly, thank you so much for including us in your podcast today. This has been such an honor and a pleasure to be able to speak to your audience today.
Thank you so much for coming on the Women in STEM podcast. Listeners, if you've enjoyed this episode, please make sure to subscribe to this podcast on your favorite streaming platform, leave a review and rating to help us reach more listeners, and follow our social medias, the latest updates and behind the scene content. Join us next week for another exciting episode. And until then, keep exploring the world of STEM and empowering women in STEM.